Welcome to Packet Pushers, the greatest ever data networking podcast, depending on how you measure it. Today, we're going to talk about cloud intelligence and network monitoring with Deepfield. We've been doing a lot of talk these days about analytics and about visibility, especially in the WAN. But when it comes to the internet, visibility is a much harder topic and requires much more than pull some data from an SNMP table. So what we're bringing on today is some guests from Deepfield to talk about their technology in a sponsored show. Let's first of all introduce Craig Labovitz to the show. Craig, please tell the audience a little bit about yourself.
Yes, hi. Thank you for having me. My name is Craig Labovitz. I'm the co-founder and CEO of Deepfield, and I've been working in the internet industry for the better part of the last 20 years, starting as one of the first backbone engineers on the NSFnet backbone project, through to other companies, including Arbor Networks and most recently Deepfield.
Craig, does that mean you have a big gray beard?
You know, I do not have a beard, and I'd like to think my hair is still glistening black, though my wife may disagree. And I try not to look at photos too often. But I have been doing this a long time, but I only think I'm getting better.
Maybe gray hair is like unicorn glitter. No, anyway, let's move on. So now Deepfield has a really unique product, Craig, and the thing that I've seen on your website is that you call it an internet observatory. Can you tell me how that works?
Yeah, so the basic problem we're solving for is the massive amount of data. The massive amount of data within data centers, the massive amount within the switches and routers in data center, and certainly within the WAN. This includes both the routers and switches, as well as all of the other devices from DNS to routing to user authentication to quality metrics that go in to running a modern data center or a modern WAN. And at the central heart of it, Deepfield is a solution that takes in massive amounts of data and allows you to make sense of it. To solve for problems around engineering, around quality, and around security.
So massive amounts of data from the entire internet or just from a localized data center?
Well, it turns out it's kind of both. So our customers are large content companies, some of the largest content companies in the world. Our customers are content delivery companies, the CDNs. Our customers are large enterprise. And we certainly have a very large customer base within telecom. These are the large consumer networks, large eyeball networks, as well as the large transit and distribution networks. So within an individual network, we're seeing a ton of data. It's their data. The data belongs to them, going to servers within their own infrastructure. But we generally are covering a very large portion, the traffic of the signaling of the servers within an individual customer. And then broadly, we've got very large penetration, certainly in North America and now in Europe, and just the sheer number of customer deployments we have and the level of engagement we have. You know, in the U.S., we're about 90% of consumer traffic that we're somehow involved in helping manage, helping ensure the quality, helping ensure the security of. So very large footprint, very large customer engagement, seeing a very large portion of certainly North American and European internet traffic.
So you're well established. You've got customers now. You're not just a startup that's just emerging. You're an established business?
We are indeed. We don't do a lot of marketing. In fact, this is one of the first public interviews I've ever given about what we do. But we are a 3 or 4 year old company. We are deployed within, I said, a very large portion of telecom, large content in the U.S. and Europe. And this is perhaps our third year actually with product in the market. Fairly quiet company. We don't spend a lot of time on marketing, on publicity, but we do spend a lot of time with our customers in growing the installed base and the value we provide to our customers.
So you're a sort of a service provider in the sense that you've been targeting that market for some time?
Yeah, we're targeting really 3 or 4 markets. We're engaged with most of the universities in the U.S. We're engaged with some of the largest content in the world. We're engaged with the content delivery. And I guess fourth would be traditional telecom. So it really runs a gambit. We definitely are not a telecom-only company. We do tend to have a large telecom base, but that's as much because they've got very large networks and very large data centers. And it turns out very large market problems they're solving for around quality, performance, and security.
Would it be fair to categorize you as a big data company? That's kind of what I'm hearing here, is that you guys are really good at huge amounts of data. So is that a fair characterization?
Yeah, yes and no. Saying big data is almost like saying SDN in 2016. It's both true and not necessarily helpful. So, I think if you're doing anything in 2016, you're doing it at scale. Whether you are solving security problems, whether you are solving engineering problems, I don't think you can be a company in 2016 and not have big data elements to what you're doing. With that said, we don't market ourselves as a generic big data company. We're not competing with, Cloudera. We're not competing with a dozen or more Hadoop companies. I think there's value to those companies. There's value to Oracle. There's value to, all these different companies. But we really are focused on solving specific problems in the enterprise data center, in the content and Web 2.0 data center, and the telecom data center and WAN around engineering, security, service assurance. And to solve these problems in 2016, it means you can't just look at a single interface. You can't just look at a single SNMP counter. You can't just look at any single metric. It really is about this wealth of data available and being able to understand how the data fits together to identify problems, to ensure quality of performance, and really to drive, orchestration, drive the engineering, right?
Well, I think you just answered my next question, which was...
Oh, see, I'm prescient. There you go.
Well, when you've got enough data, you can predict the future. So
certainly you can predict the past. But yeah, we're still working on all the bits of the future.
I was going to say, hey, I can use a traditional network management station and gather tons and tons and tons and tons of data and do something with it. And so how are you different? But I think how you're different from what you're saying here is it's not just that you're gathering a lot of data. It is that you are gathering a lot of data and then correlating that data into something meaningful so that you can apply that data and you move ahead in engineering solution.
Yeah, I think that's exactly it. The challenge when I started my career was getting data. You couldn't get anything. The network was a black box. You would SNMP poll, and it might crash the router. It might not. The data set back 20 years ago was extremely limited. You were basically measuring things on the edge. Maybe you had SNMP, you're running ping and trace route, or you were, logging into individual servers, and people were logging into Cisco's and Junipers. Today, the problem in sort of the IT space, just as an analogy, is not that there's a shortage of syslogs. There are a lot of syslog. Everything is syslogging today. The challenge in why people, for example, buy things like Splunk is not because they don't have enough syslog. The reason they buy things like Splunk is because there's too much syslog and they've no idea what's happening at scale.
Yes.
And the network is a lot more complicated, right? 20 years ago, I could log into our Netscape server and I could tell you what the traffic looked like for the entire state of Michigan, for the entire NSFnet. Today, nothing lives on an individual server. Today, there's almost never just a single path. It is a much more complicated, adaptive, bitrate, virtualized, and I can throw out all the acronyms. But it really has become a problem now where for humans to understand why does the video quality has dropped dramatically? Do I have a security threat? What do I do to add additional capacity? It's not that the data doesn't exist somewhere. It's that it doesn't exist at any rational scale or any time frame where you can make decisions around it, or where you can drive an orchestration system. Just the same way that that you can be easily overwhelmed with just the massive amounts of syslog and have no idea what's happening within a specific IT environment.
Without a system that can analyze that data and give you that information you're looking for, you're leaning very heavily on experienced humans that know the network and maybe built it back in the day and are hopefully still around to give you that insight into why video quality is all of a sudden suffering.
Yeah, but it didn't even work that well back in the day. I remember the last days of the network map. Back in the days of the NSFnet backbone, again, precursor to the commercial internet, say circa 1995, we used to make maps of the entire backbone. Every node, every access router, it was great. Getting to about 1995, though, the map, started on one page, went to 2 pages, we needed a bigger printer, and then the fonts got smaller. Even by the time you got to 1995, the ability for any one individual to tell me, right, this is the way it should work. These are the available paths. We gave up the map. The last days of the map were about 1995 before we just gave up. It just stopped being useful. It stopped being useful because the map was unreadable. And it stopped being useful because even finding those graybeards, and back then we really did have those graybeards, to actually provide that knowledge. It just, the problem becomes intractable. So you really need to start to rely on technology to help managing an ever increasingly complex data center and content delivery technology stack.
So what you're saying is that we used to have Singularity engine between our ears, but that doesn't scale. There's always just one person, and then every person who was working on the network was their own Singularity engine that could work out, if something went wrong, they went, oh yeah, I've seen this before, that's over there. Or, yeah, that's a known bug, we've seen that, that's over there. Or what we need is a way to scale out so that this type of knowledge scales horizontally within the team, within the operations platform.
No, exactly. And everything is changing, right? Back in the day, I used to log into, the way I used to make configuration changes is I'd enable and would just log into the router. And that worked for, in some cases, it still works. Although,
well, it's all we had, right? It was all we had. We didn't have a choice. But I'm often saying we need more than just SSH to be a success. It's about, and what you're saying is you bring back all the data from the devices and then feed it into a big data system so that you can now start to see what patterns, performance, capabilities, service monitoring, is that what we're doing?
Yeah, that's exactly. I think the analogy with Splunk works well, right? So the first step is you need to get the data. The second step is, can you correlate the data? And can you actually understand how the different bits? And then the third step is, can you actually have applications on top of the data that allow you to explore it, to find the specific syslog message, or to find the specific misbehaving router, CDN or interface delivery. So it really is about at scale. Can you collect data? It is about at scale. And for us, we're a little bit different from Splunk in that everything we do is in real time. Since the value proposition of figuring out a problem, 2 days from now is very different from knowing what the problem is right now. So it's about gathering the data, it's about the real-time correlation, and then it's about driving applications on top of that solve real-world quality, performance, engineering, and security problems. And indeed, that's really what we're doing. Typically, by the way, we're replacing hardware in the network. We're replacing, last time I was in a data center, it was just filled with racks of stuff. There's stuff to do monitoring. There's a lot of stuff. It looks pretty. It makes for great tours with all the blinky lights and such. But, generally folks are trying to get away from all that hardware and to find common means to drive orchestration and really the engineering, service assurance, and security. And that's really where we provide a role, where we're generally a building block in this new DevOps world of orchestration, of big data analytics, working with some of the largest, both content, enterprise, and carriers.
Craig, I want to go back to something you've mentioned as we've been talking here, kind of introducing everyone to Deepfield. And you mentioned that all of this data that's out there is important for orchestration. And I got to say, it's not immediately obvious to me how those are related, because when I think of orchestration, I think of I need a programmatic interface. I need maybe an intent engine on top that pushes that intent down into the network via that programmatic interface. But I don't really think of it as a data problem. So can you flesh that out?
Sure. I think the key word is intent. Orchestration systems are great for where you have a known intent, where you have a known intent of adding capacity, where you have a known intent of improving performance, whether it be adding VMs, whether it be setting up SDN paths, whether it be doing segment routing. Orchestration is all about executing on your intent, which may drive from quality, cost, performance, security. The tricky bit is, what is your intent? As we discussed, networks today, data centers today are incredibly complex. I can tell you stories of going into a network where we see traffic, where we see servers, and we ask the owner of the data center, right, that looks odd to us, what is it? And you get blank looks. It really is a problem of understanding what is happening in these complex data center WAN environments, of being able to correlate the data, and then being able to have human-enabled workflows or automatic workflows that can understand performance, security, and then drive orchestration to implement that intent to solve that security problem. But looking at just a large complex network today, if you had to ask me, right, where do I need capacity? Where do I need to improve quality? Where do I need to lower cost? Where do I have a security issue? I am going to see racks of thousands of servers. I'm going to see gigabits, or in some cases terabits of data that are changing second by second. I'm going to see adaptive bitrate demands. And I'm going to have really very little idea of what my intent is to drive the orchestration. So I think the central problem we solve is being one of these key building blocks of having enough correlation, having enough data, having enough, quite frankly, things like artificial intelligence, machine learning, of understanding the trends to be able to enable informed orchestration and drive that sort of virtuous closed loop of change, orchestration, monitoring. So it really is a closed loop in 2016.
I mean, you're saying you take the data and communicate that to orchestration platforms as opposed to communicating up to a human that then is going to tell an orchestration platform, all right, based on what Deepfield told me, I think we need this.
It's both. So I think in some markets and some customers, they use us with a human in the loop. In others, the environment is so dynamic, it is so complex that they're integrated directly with our API to drive their orchestration systems.
Okay, so the orchestration platform will call to Deepfield looking for specific metrics that are meaningful, and say, okay, based on these metrics, that informs this intent, and now I'm going to make these changes, and you're going to do it in an automated way, because as you say, there's just so much going on. It's such a dynamic environment. A human couldn't make a decision in time before the problem scope has changed.
Yeah, exactly. It's a matter of scale, right? If you're managing a single server in your enterprise closet, you really don't have a big data problem. Quite frankly, you don't have an orchestration problem. If you are managing 100,000 servers, 50 transit links, and different CDN partners, however many game servers, it really is a different problem. And you are not going to solve these problems by simply throwing, as we did back in the day, as throwing humans at it. In 2016, I think your approach, whether it be to IT infrastructure and things like Splunk, or whether it be to real-time dynamic data center network environments, really needs to be around layers of abstraction and automation. And that's really where Deepfield comes in, as I think Splunk has successfully come in within the enterprise IT.
Now, can you put some more meat on maybe some specifics? Maybe cite an example of how this works, just to help our engineering-oriented audience wrap their brains around this.
Yeah, sure. So, I think it can be simple as understanding traffic demands, right? Typically, what you largely solve for example, data centers or wide area networks, whether it be, east, west, north, south, is understanding what do the demands look like, how do they change during the day, where is the traffic coming from, and can you move it to somewhere more efficiently, cost-effective, performance. So Deepfield, I think this is perhaps another key differentiator. When I talk about correlation, I just don't mean that it's not just like a database where we just have, keys across the data. But when we do correlation, it really is with things we call our data engines or our logic engines. So, for example, we are data center topology and network aware. You can get data, for example, from 100,000 interfaces. You can get it today via SNMP. That doesn't actually tell you how much data is entering or leaving a given rack or a given data center, unless you actually glue it together and you can. I can't tell you the number of times I look at sort of NOCs where they've got 100,000 interfaces showing. And no one actually knows how much traffic is in the network.
No correlation of path, no understanding of a physical, it entered here and it exited here, and, therefore we now know how much data went through. It's just all these individual data points at specific places in the network.
Exactly. When there's a problem, Is this interface, in serial to these? Is it unrelated? Again, the data, uncorrelated data by itself is really hard to work with. So what Deepfield does is we are topology aware, and that's a longer discussion of sort of all the technology bits there. But, we will know what's rack, we will know what's edge of data center, we'll know what's edge of WAN, we'll know peering versus customer versus market versus POP. And it is very different. I often use the analogy of assembly. Assembly is great. I used to, again, I'm really not that old, but I did once program in assembly. Right. But, and it was great. But it was really hard to generate complex things in assembly, just as it's really hard if your language is these really small units of interface. It dramatically changes when you move to fourth generation languages, like, whatever. I won't embarrass myself by talking about different languages, but
JavaScript or Python, for example. It's really easy to add two numbers in C. It's really hard to make it render a web page in a web server in C++. Do you know what I mean?
Exactly.
And that's where we are with networking. People are still configuring networks with C instead of saying, I just need to get I need to get a result.
Right. Or worse, assembly. They're still logging into routers and changing, the days when you can log into a router and change an IGP weight, or, you're probably doing something wrong if you're doing that in 2016.
We don't need it anymore. Yeah. The days that in the modern era. I wanted to drill into, there's two questions I wanted to ask. Earlier, you were talking about how Deepfield works as a security tool. Now, you mentioned how it works as a visibility tool, so you can see what's going on, and as a performance tool, so you can get feedback about, what's happening on an interface. But you said security. Now, security for most people is, firewalls or IDSs or threatware or, proxy. How does Deepfield do that security? How do you add to the security capability?
Primarily, we're focused on security as it relates to availability. And if you look at outages in networks, today. In fact, I did a paper years ago that looked at what when networks fail and when data centers fail, why do they fail? It turns out actually most of them are not through security events. They're through configuration access to VMs or enable on routers. And it really is managing complexity, managing configuration, continue today to be the leading cause of failures. But the other side is there's also quite a bit of things like DDoS and all sorts of malicious traffic serving about. At the end of the day, for our customers, they don't always really care that much whether their $50 billion service went down because of a DDoS or it went down because of configuration change. At the end of the day, they're responsible for keeping these things running. So we're really focused on understanding in real time, how is the network performing? Where is the traffic coming from? What is normal? What is abnormal? And abnormal, again, may be due to an external actor, or it may be due to the guy Joe sitting 2 cubes down from you. Yeah. But it really is the same problem. So we really are focused on being able to understand traffic in real time and variations from that. So we do detect DDoS.
So there's two forms of security there. One is security as availability, that is preventing an outage, keeping the business integrity or the business security running, the revenues running by knowing that there's a performance issue somewhere in the network. And the second one is through visibility, what's happening on the network in terms of what traffic's there, do you know what's happening? And your tools can, because you're doing big data analysis, you can say there's this type of traffic traversing the network. You're actually, let me just query this and make sure I'm understanding this. When I say you're looking at packets, because you're collecting data from all of the edge of my network and the core as well, probably, you're actually able to see flows of traffic between all the point-to-points in the network. Is that what we're talking about?
We are seeing, every server, basically hundreds of millions of flows per second, and we're doing it all in real time, and we're correlating it all in real time and solving, again, security, performance, and engineering. And I should say it's kind of an interesting analogy. Again, I just happen to like Splunk because it just amuses me that a syslog company has grown so large.
You won't hear me getting up here. I just can't believe that syslog can be charged so much money for a syslog daemon. It's astonishing.
I know, brilliant. But if you actually look at a company like Splunk, I don't know their exact numbers, but it's somewhere in the ballpark. About half of their 40%, half of their business is security.
Yeah.
And they aren't an AV company. They're not a firewall company. They're not many, many different things. What they are is a company that has visibility into hundreds of millions or billions of dollars, billions of syslog messages, that when you can combine them in the right way, when you can have access through all that data, you can suddenly solve key security problems that, again, it's not that the syslog didn't exist before, right? And it's not that these companies didn't have firewalls. And I've been in these data centers. They've got everything.
Yeah,
but still,
all the tools are there, but they can't harness them to turn it into valuable information.
But, and again, I used to do stuff with the federal government, and we'd go into these NOCs, and it's just no one knows what is happening. And you see alerts from a tool, and is it legit or not? And it is really not, it's really a data problem, right? And the central problem is security. It's false positives and false negatives, or put more succinctly, incomplete information. So whether you're Splunk or whether you're a Deepfield,
I think Splunk's success as a security tool is much of a testament to how poor quality the actual security logging engines are. As much as, like Splunk worked and all the security ones didn't because they were so horrible. But the second part of my question I wanted to move on to was data centers are changing all the time, and the WANs too. We're talking about MPLS or EVPN and BGP in the data center to do L2 over a fabric. Or at the edge of the network, we're moving away from routers in a PHY underlay on a private MPLS service, private WAN, to internet as bandwidth. Are you able to cope with those? Does your data ingestion process or does your analytics tools change in those environments, or you just take the whole lot and away you go? It doesn't matter to you.
Yeah, again, typically our customers tend to be, the larger accounts, just where we happen to focus from a go-to-market and from company. So we generally are dealing with customers that are really at the bloody edge of some of these adoptions. And again, these are some of the largest content guys in the world who are really just being driven out of necessity to adopt the new technology. As well as on the telecom side. We're at the forefront of all of these different initiatives, from whether it be the tunnels, from whether it be some of the I always want to be careful here. I'm always in danger of throwing out names, and I don't want to get into too much detail as it might shed light on our customer base. But it really is a very dynamic environment where typically the larger accounts and the more sophisticated content delivery and telecom are all really changing their installed base and the technologies that they're using.
Craig, I want to go back to something we were talking about earlier. We were getting into correlation. In other words, how you take the data that you have, correlate it, make it useful, and then now I can make interesting decisions about it. Now, I'm thinking about application delivery. I mean, networking is one thing, right? You guys are topology aware. That's great. Not, a lot of people have solved that problem. But then as I move up the stack, I'm really looking at application delivery. Do you guys get into that world as well?
Yeah, we do. And we spend a lot of time understanding how both what services are and how they're delivered. And by how they're delivered, I mean, if you look at any over-the-top service, it's going to involve, in 2016, a CDN component. It's going to involve compute, storage, analytics. So we actually spend an awful lot of time with enough data at scale. We can actually understand how any over-the-top service is being delivered from any part of the world at any given time. We can understand how that's changing, and we can understand the performance implication when there's a problem with any one of those components. Again, we're a very long way from, when all traffic came from the Netscape server in your network. And then we're similarly doing things for internal services. This is true of some of the financial companies we work with, as well as the game companies. It really is being able to understand how all of the different components within the data center work together, where there's authentication servers, where we can automatically identify the data servers, and really putting all of that together. So at the end of the day, you are not looking at thousands of interfaces. You are not even just looking at parts of your network. But where you can start to operate, to orchestrate, and really do engineering at a level of these different components. So yes, quite a bit of our technology, quite a bit of our patents are all around these aspects of automatically building in. We call it service logic, automatically monitoring and identifying how the services are built and how they change over time.
Okay, so here's a scenario. I'm running hybrid cloud. I've got a private cloud deployment. I put some things up in public cloud depending on what services I'm doing. You could tell me things like, I'm thinking out loud here. You have slow authentication because your server that's standing up in AWS is actually hitting something in your private cloud. And then, there's this trombone effect going between the two due to high latency.
Yeah, exactly. So we do a lot of that. I should say that we perhaps there's companies that just focus on application performance management. I still think there's a need for some of those companies in branch offices and enterprise, but certainly for scale and folks who are dealing with very large infrastructure at scale and don't have complete APM deployment, we can definitely solve some of those performance and monitoring problems.
Now, okay, so how do you do that then? Do I have to run a bunch of agents and all of that? Is it just transactional logic that gets fed into the engine?
Yeah, it's both. Typically we are a software solution. We typically, it really is, I think, customer dependent on what they have available. We really like to use as little additional kit in the network as possible. So typically we're leveraging as much as we can on existing DNS, on existing servers, on existing capabilities of your routers and switches and servers. So we integrate. A lot of our strategy really is, we call them connectors. And you'll see a similar messaging from Splunk, where we've got built-in connectors to take data from a whole range of network devices, a whole range of servers, a whole range of DNS, where we can just automatically import streaming real-time data from these devices. In a few cases, we actually do provide agents. It's not a large part of our business, simply because we like the scale better of using existing kit and existing hardware, software that you have on your servers or others.
Building agents kind of went out in the late 90s, early 2000s as a model because it just didn't scale, and it wasn't, you get into all sorts of difficult operational issues.
Exactly. It's a thing. Oh, I got to install an agent. Oh gosh, here we go. Yeah. So not having to is preferable.
And you really don't need to, right? Again, I think folks need to, the world is changing, and often we talk to folks who don't realize they've got all these capabilities built in to their existing infrastructure. A lot of us, again, those with gray beards, grew up a time where this was just unimaginable, where it's SNMP or bust. The fact that you could get streaming telemetry,
SNMP or TCL,
but the capabilities, and it's really where the market's competing, right? As we've seen commoditization, as we've seen, merchant silicon, all these trends, the market really is not just speeds and feeds in the network. It really is about what is the operational cost of running the network. Is one of the key drivers today. This is true of, whether it be Meraki, it's true of, it's really where you're seeing a lot of the competition and a lot of it's really the wave we're riding.
It's not just about the cost of operating the network. It's the cost of operating the network predictably, reliably, making a change and making it happen all the time. And you have to find new ways of operating the network to get away from the old stuff.
Exactly. And I should tell you a story. My last company, we were a security company. We had all of our customers. They used to be the folks that would wear black, all the security at the different enterprises. They didn't want a UI. They didn't even want. They really wanted. It was a kind of a geek chic thing. They wanted to log into the devices, and the harder it was, the better. And there really was an element of the industry that was about that. I've got to tell you that's gone. They may still want that, but their bosses have so far moved on, and it really is the cost of ownership today. And where it just doesn't, nothing else scales, and worse, you don't get the predictability. You just can't rely on that one guy to manage this ever-increasing infrastructure anymore.
Going back to the notion of application delivery, do you deal with OpenStack?
We do. We don't do. We are engaged with OpenStack. I think that we are working with customers. We're typically in the lab stage with some of these. We don't have as many production deployments around it, but we are engaged with different OpenStack efforts.
So you could talk to OpenStack and pull data out of it as part of your ingestion process and figure out what apps are getting stood up where, look at VMs, and then know, okay, coming off of this OpenStack compute node, I've got these VMs running, and they're plumbed into the network like this, and then make a graph. What would you call it that shows the application delivery happening?
Yeah. So, by the way, it's not just northbound or southbound. We actually do both. When we talk about connectors, it's both about ingesting data from other devices as well as pushing APIs or meaningful data to other devices. And in fact, at least in one of our large customers, we're doing exactly that. They're not using OpenStack per se, but we are engaged. We are actually in real time tracking what's running on every single VM, where it's running, who the business owner is. And whereas before it was just no one knew what was running a data center, we now know to the individual, to the business unit, the business owner, to the application. We know what's running. We know the performance. We know the cost. And we're doing it all in real time. But
okay, this is actually really important because you're not just feeding data to the geeks sitting there with 5 screens on their desk monitoring stuff, and you're actually impacting. There's a business impact here if this service is underperforming or is unavailable that you're correlating as well.
No, exactly. And, it's so hard today. Today, if you don't have, if you don't have Splunk, if you don't have Deepfield, it's just this massive data. We can actually identify, and like one of our first use cases was just, do you have data centers in Europe that are actually serving, do you have specific applications that are just so badly misconfigured, they're serving San Francisco? The default answer without this level of data is you build more data centers. Everyone's running out of capacity. The old days it used to be run network bandwidth, right? The new bandwidth is running out of server capacity, or actually running out of power in data centers. So you've got these resources that are geographically critical, and you need to understand locality of delivery. You need to understand who's actually used. It's great that anyone can run anything anywhere. It's also horrible that anyone can run. You need to know what's running,
all of that.
And it's not just what's running on the server, but you have to understand how all this maps to the other resources. Like, is a given application just banging the heck out of your storage? Are you just killing traffic because no one had the incentive to even spend a minute to optimize the geolocation delivery? So it's just, there's a downside to things being easy in 2016 from standing up a VM from an orchestration. And that is you lose, it used to take some real effort to configure something. And they used to have to be thoughtful about what they did. When you can launch 1,000 VMs with a keystroke, the equation changes a little.
One more question about some more complex service provider scenarios. I'm assuming IPv6 is kind of like, whatever, IPv4, IPv6, we don't care. Is that about right?
Yeah, it's kind of like table stakes for us. That you don't build a company in 2016 without APIs. You don't build a company in 2016 that doesn't support v6. So
except for those companies who do.
Except for most of them, yeah.
Yeah, for most of them, yeah. I love it when you say things like that, and I'm thinking to myself, and no, that company doesn't. Yeah.
Well, you don't play in our space, right? I think it's one thing if you're sort of SMB, right? You're coming out with a new enterprise firewall. But if you're dealing with the largest content providers on the planet, if you're dealing with the largest consumer providers, the largest hosting provider on the planet, top V6 is definitely top of mind. Simply because they have no choice. They don't have addresses. So they're all there. They've been there for many, many years. So all of our customer base is there. I expect as we go down market, that may be less of an issue down to smaller SMB and smaller companies who may or may not have V6 or in some cases even heard of it. But certainly our customer base is very focused on V6.
Yeah, the down market's going to start caring about IPv6 when all of a sudden they can't do something they want to do. They can't communicate with someone they need to because they're not running IPv6. Then it'll be a thing.
Yeah, the best thing for V6 adoption was running out of V4 and suddenly having real money associated with V4 addresses. It was never an engineering problem. It was always an economic, first and foremost.
Well, related to V6 deployments then, NAT and carrier-grade NAT, in your analysis, looking at app delivery, is that part of the equation?
Oh, well, it's very related to V6. So, I think in a lot of our customer base, there's folks that are experimenting with carrier-grade NAT, certainly, mobile and others. I think generally we are seeing amongst our customer base, I think they're really pushing on V6 for just this reason. I think that the scale, the management, the performance issues, where a lot of them have done very large-scale trials, really have just been problematic. So we really are seeing, I think, this push to V6 for that reason. But we are environments where there's certainly NAT, and we certainly are engaged with mobile providers where all the traffic is NAT. And we do work with those NAT devices in that we are getting streaming data from the NAT devices where we are tracking all of these different mappings between the different domains. And again, it's a big data problem, right? It's a lot of stuff, but it turns out the data is there. You just need to be able to get it. And the really tricky bit is, can you do it in real time? That's where we spend most of our time. Is correlating data weeks from now, days, hours from now is totally different problem from can you correlate it in real time?
And that's what Splunk does. It's a batch processor. At night, It'll run an analysis across the log files, or it's like going back to the 1970s when you'd run the general ledger batch every night or once a month.
Now you're sounding like a gray beard. It sounds like you've got direct memory of the cards. But that's exactly it. That's one of the ways.
I've got memories of waking up at 2 o'clock in the morning when the batch failed. Because it took weeks to set it up and to run, and when it failed, the world ended.
Yeah, and that's one of the places we're really different from companies like Splunk, in that most of our focus is on these real-time issues, because security a day from now or tomorrow is just a totally different value proposition as detecting a DDoS attack now. Solving a performance issue is about now. And that's really, we call ourselves sort of an operation intelligence company where the focus really is on these operations to ensure quality, performance, security. And that really is the focus, and that's a tricky bit. It'd be so much. My life would be so much easier if we were batch processing. Real time is the tricky bit.
Craig, this has been a pretty interesting presentation. Statistics has been one of my favorite things over the years. I've worked with a lot of network management platforms. I'm one of these guys that goes all the way back with SNMP. That's what I started with and what I spent the most time with over the years. And to hear the market evolution, what's changing, and you kind of know instinctively as a network engineer that SNMP really doesn't cut it because it's broken in so many ways. It's functional, it serves a purpose, but it doesn't take you anywhere. It just makes a lot of pretty graphs. So to hear, what you guys have taken on to put usefulness around that data is pretty interesting, especially that you can do it at massive scale. So anybody listening to this show, no matter what your needs are, Deepfield is going to be able to ingest as much data as you can throw at it and give you back data. That is, it's really got my brain spinning because, again, going all the way back to my comp sci days, stats were my favorite thing. Anyway.
Yeah, no, I appreciate it. I just want to emphasize, too, that we certainly do SNP, but we really are about some 70 different connectors that we support today. So we do syslog, we do SNP, we do NetFlow, we do BGP, we do IGP, we do DNS. We've got 50 specialized connectors for a range of different security as well as other cloud providers. So, I am amazed how far SNMP has come. I never thought ASN.1 would make it into the next century, but here we are. But I do think the world is changing, and I'm very pleased with what I see from most of the server vendors and most of the router and switch vendors in terms of their adoption of sort of the next generation of both orchestration as well as streaming telemetry. So good times are in front of us.
Well, Craig, how can people find out more about Deepfield if they want to talk to you guys?
Well, generally, certainly our website works. We're at www.deepfield.com, and we're at all the major conferences, whether it be NANOG or RIPES or different server meetings and hosting conventions. So, always happy to chat, and certainly we can reach us on our website.
What about you personally? Are you social? Do you blog or tweet, anything like that where people could follow you?
That's a good question. I used to do quite a bit of blogging. I've become a little bit, turns out running a startup has made me do a little bit of a hermit, so I don't get out as much. But I do show up at different networking conferences. I haven't blogged in the better part of a year, though our marketing people are telling me I better get started. But I think our website's the best bet, and certainly I think a lot of the folks in the industry I've met or know how to reach me directly as well.
Well, that's great. Thank you very much for taking the time for sponsoring Packet Pushers today. Greg, any parting thoughts from you?
Well, this trend of big data and then analyzing the data to do something is something that's becoming quite well known. We're seeing that path walk fairly often, aren't we, Ethan?
We are, and the network analytics trend is going to continue to grow. We've talked to the folks from OpenConfig about that. I've talked to some folks from Juniper, and telemetry, streaming telemetry continues to grow. That's right. And so I'm starting to see the network as not just about connectivity, but also as your networking devices, your routers, your firewalls, your whatever they are in the network, are actually telemetry devices collecting like temperature, like a temperature sensor that they use to predict the weather. You have the more of those you have, the more visibility you get in your network. And the Deepfield product, actually, the thing that I like to see emphasized here is the real-time nature of it, the fact that they can ingest vast quantities of data and actually give you an instantaneous response. And that just pops my mind on a few things. Obviously, you need bandwidth, and there's considerations with deployments, but that idea of ingesting vast amounts of data and just reacting immediately with alerts, or you looking at it, or it signaling out to some other orchestration engine, that just changes the way you think about my network, I think. Yeah, I agree. And it's not just vast amounts of data, it's vast amounts of sources of data as well, as Craig punctuated that right at the end for us, all the different connectors that they have. Well, I think that about does it for the show today. And so to the audience, thank you for listening to Packet Pushers. You can find this and many more fine free technical podcasts along with our community blog at packetpushers.net. Thanks to Deepfield one more time for sponsoring the show today. You can follow us on Twitter at Packet Pushers. You can also find us on LinkedIn. You can like us on Facebook. You can rate us on iTunes. And then last but not least, remember that too much networking would never be enough.